So hello everyone. I'm sorry for the late AVL for our lesson 3 and 4. So for this video, I'm just going to skip lesson 3 because it is just all about on representation of rational function, and it's focusing on how to graph or how to plot a table on a Cartesian plane. So let me have just a short review. So again, if we have a Cartesian plane, so we have this is our x axis and this is our y. So if we have the value of 4, 2, so this is the value of your x and this is the value of your y. So if you have here 1, 2, 3, 4, and then your y is 1, 2, so you're just going to get the intersection of these two. Okay, so this is, so your x is 4 and then your y is 2. So that is how we're going to plot coordinates in the Cartesian plane. Let's have another one, -1 and -5. So the value of your x is -1 and the value of your y is -5. So -1, then you have -1, -2, -3, -4, and -5. So -1 and -5, so we have here. So this is our -1 and -5. So remember, we have in this coordinate, we have 4 quadrants. So quadrant 1 composed of positive x and positive y. Quadrant 2 is we have negative x and positive y. Quadrant 3, quadrant 3 we have negative x and negative y. And quadrant 4 we have positive x and negative y. So this is just a short review in graphing a coordinates. So let's proceed to lesson 4, which is the graphing of rational functions. So please have with you your module. So in graphing a rational function, in our previous video, we already talked about solving rational functions, specifically rational equations and rational inequalities. So these are the important concepts that we need to know. The domain, of course, the domain is the value of the x's. The range are the values of your y or the output. So let me just have you this. So this is the output, this is the input. Okay, then the zeros of the functions are the values of x, which the functions make the function 0. The real numbered zeros are also called x-intercept, and the y-intercept is the function when x is equals to 0. Let me have you an example later on. So okay, so let's start with on how to find the domain. So as what I have discussed from the previous video, when you have this, you are going to consider the denominator. What makes the denominator, what is the value of x that makes this denominator 0? We know that the denominator where b is an element of a real number should not be equal to 0. So because it will be undefined. So what number can be substituted here in x to make this denominator 0? So we have -2. That's why we have this set builder notation. How to read this one is x is an element of real number. It is a set of x that is, this one symbol is that is element of a real number such that, what is this such that? This is such that, the symbol of such, this one, the line vertically, such that x is not equal to -2. So that is how we're going to read this one. Okay, so set of x, that x is an element of a real number where such that x is not equal to -2. So that is the domain. Okay. Okay. Next, the what's this? So let's move on to Xintercept. So how are we going to find the Xintercept? So turn your page to let's move on tayo na lang sa summary. Kindly turn your page to page 19. This one, example number 6. Okay, and we have here the table summary. Okay, so find the domain. So we are going to find these things: the domain, the y-intercept, the x-intercept, the vertical asymptote, the horizontal asymptote, and the range. So and the range is on the graph na, so that will be seen on the graph. Okay, so domain again, we should know the what numbers can be substituted into the x. Of course, considering the fact that the denominator, if it is a fraction, should not be equal to 0. So that is how to get the domain. Now let's have y-intercept. So in y-intercept, the goal here is if 0 is not in the domain, then there is no y-intercept. Okay, so if 0 is in the domain, the y-intercept value function is x is equals to 0. Let's have this example. Example number 6. So how are we going to find this x-intercept? So in finding the x-intercept, no, I'm talking about y-intercept. So y-intercept, you just substitute x is equals to 0. So all x's here will be substituted by 0. So as you can see here in our examples, all x's here, this is the formula, this is the given. So all x's here are substituted by 0. So what we have left is 3 over 4. Okay, so this 3 over 4 here is our y-intercept. Okay, again, how to get the y-intercept? Substitute 0 sa tanang x here from the given equation, function rather. Okay, next, how to get the x-intercept? So refer to the x-intercept. Find the values where the numerator is 0 but the denominator is non-zero. So do not be confused, just matter the numerator. So you equate. So based on our given here from our examples, we have 3x plus 1, that is our numerator, and x minus 3, so that's why we equate that one to 0. Okay, so 3x plus 1 equals 0, so we have x is equals to negative 1/3, and the other one is x minus 3 equals to 0, then x, so we have 2 x-intercept. Okay, again, when you say x-intercept, refer to the numerator where you equate by 0. Okay, this one is this here, equation here, you equate that to 0 to find the x-intercept. Okay, so if you have 3 here, then you have 3 x-intercept. Okay, so it depends upon the given function. So let's move on to vertical asymptote. So in vertical asymptote, we have here, find the value of x where the denominator of the reduced rational form is 0. So in vertical asymptotes, we also have, kung sa x-intercept, the numerator atong gi-equate to 0. In this time, when we look for the vertical asymptote, we refer to the denominator na po. So denominator. So we equate the denominator by 0. So we have here 2x minus 1 equals to 0. So we have x is equals to 1/2, and x plus 4 equals to 0. Then x is equals to negative 4. So as you can see here, we have two different vertical asymptotes. Okay, and then the horizontal asymptotes, how are we going to find one? We'll refer to this one, page 18, where let n be the degree of the numerator, again, Cn, degree or exponent in the numerator, and m, the degree of the denominator. So if n is less than m, the horizontal asymptote is y equals to 0. If n is equals to m, the horizontal asymptote y is equals to a over b. Okay, that we are referring here the numerical coefficient, where a is the leading coefficient of the numerator and b is the leading coefficient of denominator. And if n is greater than m, then there is no horizontal asymptote. So let's have an example here. Yeah, page 18 again. Example number 2. Okay. In example number 2, we have here asymptote. Let me tell you what is asymptote later. So if you can see here, what is the exponent here? We're just going to the leading coefficient, ha? So what is the exponent in the numerator? 2. And then the denominator is 2. So what are we going to consider here? N is equals to, let's have a letter A, B, C. So we are going to use letter B, where n is equals to m. Therefore, we're going to make use of the leading coefficient of numerator and the denominator, which is 4 over 1, or that is equals to 4. Okay? Okay, so that is our, we have seen a previous example can be determined by looking at the variable of functions. Okay, so as you can see here, thus this means the horizontal asymptote is at y is equals to 4. So look at the degree, the numerator or the exponent, and the exponent of the denominator. If it is equal, then you refer to the leading coefficient of the numerator and the denominator. So 4 divided by 1, muna mahimo siyang 4. Let's have example number 3. So again, what is the degree or the exponent of the numerator? We have 2. Okay, 2 erase. Alright, so 2, and the denominator is also 2, so equal. So again, we are going to refer to letter B. So leading literal coefficient, we have numerical rather, so 2 over 3. So that is our horizontal asymptote. Okay, let's have example number 4. What is the exponent in the numerator? 1, right? Okay, that's good. What is the exponent in the denominator? So 1 is less than 2. Okay, go back here, A, B, or C. So it is in A. Therefore, the horizontal asymptote, that is y, is equals to 0. Okay, so again, when we are talking about horizontal asymptotes, we are going to refer to the exponents of the numerator and denominator. Let's have example number 5. Exponent of the numerator is 3. The exponent of the denominator is 2. So 3 is greater than 2. A, B, or C? Yes, C. So therefore, there is no horizontal asymptote. So the function has no horizontal asymptote. By the way, what do you mean by asymptote? So when you say asymptote, if we're going to graph an asymptote, okay, horizontal, so it's in x value because it's in the horizon. Okay, so supposedly your horizontal asymptote is nakahigda siya ha, because it is horizon. So say for example, by the way, horizontal asymptote, we're referring to this line. Horizontal man na siya, so pahigda. The value of that one is on the y. So example, our horizontal asymptote is 2. So when we graph this one, ang graph siya, it will closer, but it will never ever touch. Char. Murag close mo, pero di gid pwede maging kamo. So again, so it will make bring it closer to the horizontal asymptote, to this line, to this horizontal line, but it will never ever touch that line. Closer lang siya, di lang gid siya mo touch ani nga line. Okay, so that is asymptote. Okay, magsubay lang na siya sa linya, pero it will go closer and closer, but it will never touch that asymptote. That's why it's called asymptote. Okay, so again, let me have the summary for domain. You just need to look for x or a number to be substituted by x. Be careful if it is a fraction because the denominator should not be equal to 0. Y-intercept is you substitute all x's by 0. So y-intercept, all x's should be substituted by 0, numerator and denominator. X-intercept, the numerator will be equate to 0. Okay? And the vertical asymptotes, denominator will be equate to 0. And then horizontal asymptote, refer to the exponents. Okay, so once you're done finding the domain, y-intercept, x-intercept, vertical asymptotes, horizontal asymptote, by the way, this range can be found in our sign table. That is the output, the outcome. Okay, sign table. So as you can see here in your module, we're now going to plot the points. So we already have now the we already now have the y-intercept. So when we say y-intercept, we are referring to the y-axis. So that's why we have here the point. Let me take you to zoom. So this one. So this is the 3/4. Okay? So that is the 3/4. This is the what? This is the y-axis. Okay? Now what is this? Excuse me. That is negative 1/3. That is now our, what's that? The x-intercept. It's in the x-axis. Okay? X-axis. You plot first all the y-intercepts, the x and y-intercept first. And then we also have 3. So this one, the second x-intercept. So that's all. Those two are in the x-axis. Now let's move on to vertical asymptotes. So in vertical asymptotes, from the word vertical, so our line should be pa up. So from the word vertical, so when we plot the vertical asymptotes, we are going to plot the numbers on the x-axis to have a vertical line. So as you can see here, the vertical asymptotes here is 1/2. So we have here the 1/2 kaninga line. That is 1/2. Okay. And know that we have two vertical asymptotes. So we have -4. So this is also the second vertical asymptotes. So we have, as you can see, you have seen this broken lines here. So again, you can see here that we have two vertical asymptotes. Now, how to plot the horizontal asymptotes? Because horizontal asymptotes is pahigda, so we are going to plot that horizontal asymptotes on the y-axis to have our horizontal line. So since our horizontal asymptotes is 3/2 or 1.5, so we have here center of 1 and 2. So we have here, so as you can see, the horizontal asymptote, the horizontal broken line. Okay, let me just write this one. So this is the horizontal asymptote. This one is vertical kaning duha. Yan. Vertical asymptotes. So we have two vertical asymptotes. So it's not always that there are two vertical asymptotes, one horizontal asymptotes. It depends upon the given function. Okay, so that is how we're going to plot the domain, the x-intercept, the vertical asymptotes, and the horizontal asymptotes. Okay, so when I get back, I will explain to you more on this page 20. So let me cut this video because it's very long now. So let's continue to our next video. If you have questions and clarification, you can just PM me or ask me to our group chat. Thank you.